India aspires to be a developed country by 2047. And India hopes to do that with the fundamentals of science and technology, which are solidly based in India. I have with me Professor Yamuna Krishnan. She's a professor of chemistry at the University of Chicago in the United States of America. Namaskar, ma'am.
Namaskar.
But why I talked about that science should be grounded in India, Professor Yamuna Krishnan, trained in India, then shifted to the University of Chicago and is one of the pioneers of DNA technology. And as full disclosure, both of us share several alumni, and she was part of the Indian Institute of Science, Bangalore, which is where I was also trained. And then University of Chicago runs the Marine Biological Laboratory at Woods Hole, one of the finest laboratories of the world, another place where I was trained. And both of us also have a common mentor. Let us start with telling me about your mentor.
Well, I was excited into science by this wonderful older professor. I just knew him as Uncle Krishnaswamy, but this is Professor S. Krishnaswamy, who was then the Vice Chancellor of Madurai Kamaraj University. And, my father is an architect, and my mother was trained in the arts. She's a literary person. So, it was actually during the preparation of one of my mother's, school textbooks where she was interacting with Professor Krishnaswamy. And then he sort of got me interested in repeating small experiments in my home that I'd sort of learned in class. And that interested me in science. And that's how I ended up doing science, something that neither my father nor my mother did. Uh, so a really wonderful gentleman who saw the potential of curiosity in every kid, right? And sparked that.
Wonderful. Then I must also disclose Professor S. Krishnaswamy was the first person who published my first journalistic writing long back in the early 80s. It was a journal called Biology Education, where we did a cover story on the Namdafa National Park. And it was Professor Krishnaswamy who was the editor in chief of that magazine. So here you have two biologists with a common mentor, not knowing that the mentor was the same person and having now talking to each other. Uh, what a wonderful feeling, Professor Yamuna.
Yes.
Professor Yamuna, tell us a little bit about your research work.
Yes. So, I was always interested in sort of trying to build things when I was a kid. And then I discovered DNA. After I finished my PhD in the Indian Institute of Science, I went to University of Cambridge. And there I worked with Shankar Balasubramanian, a very well-known scientist who has actually invented this, next generation sequencing with DNA. Today we get our DNA sequenced, right, all the time. That technology is actually developed by Shankar. And that's when I suddenly got mesmerized by this beautiful molecule. So I came back to India and started building small devices using DNA. And I moved from a chemistry department, I moved to the National Center for Biological Sciences, where I was surrounded by biologists. And here was this sole chemist sitting amongst, all the people who are studying fruit flies, who are studying worms, who are studying, cell death, all sorts of interesting things. And suddenly, when I looked at biology, there were so many problems that we could study. And then I started building for the biologist. One of the things I wanted to understand was, I just got introduced again to the living cell. So this is after several years of not doing biology. For maybe after I left school, I never did biology. I came back to this institute. Suddenly looking at the cell again, I saw that it had all these little organelles, small compartments that are present inside living cells. And, just like organs of the body perform specific functions for the body, organelles inside cells perform very specific functions for cells. And they're all like little compartments, all floating around in the same soup. And I was wondering, what is inside these organelles? What is the kind of environment that you have there? But I went around.
It's like an ecosystem inside there.
Yes, yes. I went and I asked all my colleagues, what is the level of sodium and potassium and everything that's present inside these organelles? And nobody knew. And so I thought, well, if I am such a good chemist and nobody knows the answer to a very chemical question, let me try and develop a way by which I can find out what the answers are. And so, just from a purely academic, basic point of view, that, can we advance the bleeding edge of knowledge? I developed a way to measure the levels of ions inside our organelles. And thereby, when you're trying to see something new, you will always be able to say something new. And so once we started mapping out the levels of different ions in organelles, so many applications arose. So it came from very fundamental science, right? When you're poking fundamental science, the inroads into understanding disease, developing therapeutics, they all just come naturally.
What is your work on DNA nanotechnology machines? It sounds fascinating, where DNA is a fundamental genetic block.
Yes.
But to use that as a machine?
You want to think about these as little devices, right? So anything where you take a collection of individual things, join them together to make a sort of a small entity on the nanoscale, but that entity performs a function. You've now created a device, right? So even a little tweezer is a device, right? You could just have two things which sort of come together. It's a device. Two chopsticks that come together. It's a device. So if you can do that, but on the nanoscale, that will tell you something about the system. That's a device. So what we've done is we've taken small strands of DNA. Each strand sort of carries one functionality. One is detection chemistry for an ion. The other is a reference chemistry, which allows you to measure. And the third is a small signal that allows the device to grab onto a protein that's present at the cell surface. Then the device is able to go inside an organelle and get enriched over there. And then it detects the level of ions and tells you what the level of ions are. And so it's a series of small strands that all get together to give you a function. And so it's very, very simple, but it's modular. Right. And because it's modular and it's simple, this concept allowed us to map out the level of ions in a whole range of organelles inside cells. And this was interesting because these were some of the last remaining unexplored spaces inside our bodies. And because they were unexplored, we could never use the chemistry inside them to understand how diseases started, or to diagnose diseases, or even to treat diseases. But now that we are there, a whole range of applications is now possible.
So have they been deployed, or is they being used for therapeutic purposes or for diagnostic purposes, some of your work?
Yes, so I should actually give you a disclosure for myself, right? One is, all of these, the entire technology has been patent protected. And then what we've done is there are two major applications. One is in diagnostics, where we leverage the knowledge gained in terms of, what are the ion levels, to be able to diagnose diseases, basically neurodegenerative diseases, much earlier. That's being done in a company of mine, which I've co-founded with Divya Venkat, who is the CEO based out of London. And that's trying to bring to market Alzheimer's, a way to diagnose Alzheimer's much earlier than we are currently diagnosing. And basically a company that looks at brain health. And the second is we are laying the foundations for organelle-targeted therapeutics. We've all learned about drug targeting in terms of targeting a specific tissue or a specific organ. But now we are going one level of hyper precision. That is, in a specific cell type, a specific organelle in that cell type, right? And so this has now applications in cancer. So I've just started another company co-founded with Professor Lev Becker, who's a cancer biologist at the University of Chicago. This is still very early days, but we now, in the beginning, we had sent our devices to cells in culture for diagnostics. But you can imagine, instead of sending something that will report to you the level of ions, you could also send a therapeutic to that location. And so that is another aspect, which is therapeutics. So there are these two companies that I've co-founded, SCR for diagnostics and Macrologic for therapeutics.
So maybe you can send one of your machines and ask it to switch off the powerhouse of cancer cells, the mitochondria, and that would kill the cancer cells. I don't know whether you're exploring something like that.
So, I would actually suggest a slightly different approach for cancer. Instead of going and killing a cancer cell, right? See, you and I are getting cancer all the time. We're speaking, and there are cells that are mutating into cancer cells right now. But the difference is our immune system can take care of it. Our T cells and B cells and macrophages immediately see this weird type of cell and kill it. So the fact that you have a tumor, right, is actually a failure of the immune system. So what you want to do is to let the immune system see your cancer, your tumor, and the immune system should be able to will then just take care of it, right? And so what you want to do, more than killing a cell, is actually to reprogram it. And once you reprogram it, the rest of biology takes over. This has the potential to overcome what's called resistance, right, to chemotherapeutics. So many times we try to kill a cell, and the cell actually life just wants to live, right? So this causes what's called a selection pressure. And then that cancerous cell mutates and becomes even more virile, even more, deadly. And when you're trying to mutate something into another form, when trying to reprogram the cell, you're not giving it that selection pressure. You just changed it. So there's no desire for the cell to become worse than it actually was, right? So that has a potential of sort of bypassing these resistance mechanisms. And that's something I'm excited about.
Would you say it's like taming cancer?
I would say it's brainwashing cancer.
So brainwashing cancer to behave normally.
Yes.
Has this been deployed?
No, we've just published the first papers in Nature Nanotech in 2021. Then we've started this company, and right now we're sort of working out some of the. There are a lot of things you have to do before you can take it to Series A funding and things like this. So there's that incubation time, and that's where we are at the moment.
Well, I should tell also my audience that Professor Yamuna Krishnan works at the University of Chicago, a very famous university for many, many things and many Indian connections. Nobel laureate Professor S. Chandrasekhar used to work there. Carl Sagan, the famous cosmologist, was at the University of Chicago. And all of nuclear energy of the world really started with the Chicago pile at the University of Chicago in 1942. And the Fermi Lab is also run by the University of Chicago. So you can imagine the kind of enriched place in which Professor Yamuna Krishnan is working. Is it an exciting place to work at the University of Chicago? I'm told it's very cold.
It's cold, but the science is hot. What I really love about Chicago is it's a very scholarly approach to science, right? Where you really go deep into it's famous for its depth. There's very little drama and flash and this and that. It's really about you strip away all of this drama, flash, glamour, and then you really get into deep, gory detail, and you solve hard problems. And that's really what Chicago is about. It's about solving hard problems.
Any,
So
any other alumnus with Indian connection from University of Chicago you may want to name?
A.K. Ramanujan, I would say, I think. Yes.
What a connection. So
There are so
you,
many people at University of Chicago, not just in the science, but also in the arts. There's a very rich connection from the arts as well. Uh, my mother is from the literary world, right? So I know that there's so much interaction. But that's, I think, the what makes a great American university, right? You have vibrant arts, you have vibrant science.
and it was one of the first universities to set up an India Center in New Delhi.
Yes. Yes. Because we realize that, at the end of the day, you cannot the world is connected. It's in fact it's only going to become hyper connected, and the only way that we can solve big problems is through working together on different sides of the globe, right? Progress only in one place doesn't mean it's true progress. You have to be able to bring everyone to thermalize, because we all have different strengths.
Sure. And Professor Yamuna Krishnan also has a connection with the Ashoka University. Can you tell me a little bit about that connection?
So I was brought on board by Professor Vijay Raghavan, who is heading the Science Advisory Council of Ashoka University. And, I had only heard a lot about Ashoka University because of the vibrant arts program that they had. And one of the things that I found very interesting, even before I had sort of left, and I had been watching this because it's a very important experiment in Indian education, where there's this emphasis on critical thinking and developing that at the level of undergraduates. And I think for me, this is a very, very, very important thing if we are going to make visionaries for the future. One of the things that I felt a long time ago, because I came through our system, I value our system, and it's very important in terms of inculcating discipline and everything, but it doesn't teach you to ask questions. It rewards compliance, right? And it rewards writing things verbatim without understanding anything. And I believe that that is a legacy that was handed to us by the British, right? Because they just wanted to have robots who will do all the scut work so that they could concentrate on different things. So we were handed an education system that made people not think, just be human calculators or human accountants and do a service and give it to you. Then, of course, we got independence. So the last 50 to 70 years, we suddenly realized we have to build capacity in terms of doctors, lawyers, engineers. And so we started all these IITs and management. Again, we give them problems, and then they've become fantastic at solving the problem, right? So I need you to make this new device. I need you to do this new operation. They will figure it out, right? But then we never asked our students, but still somebody has to give them the problem, right? We never created a range of students who would look around and ask, what are the problems? Why should somebody tell me what the problem is? Why can't I see what I can do to change things? How does one change the paradigm? How can one develop one's own vision as opposed to execute on somebody else's vision? We don't have a Princeton, right, in India. But that comes from teaching students how to think critically. And that's why, I had kept an eye on Ashoka. And when they started this new, they expanded into science. That was when Vijay contacted me and asked me, would you like to come on board for chemistry? And then I said, I'm so happy I was asked, because if there's anything that I would like to contribute my time to, it would be to make this experiment succeed. And what gets rewarded gets repeated. And we need not just one Ashoka, we need many more such universities.
Wonderful. Let's spend a little time on how science is international and how you need mobility. Some say you parachuted out of India when things were going hard for you. Is that a fair statement?
So things were never going hard for me. Uh, I want to say that, um, when things are hard, that's when I dig down. Right? I dig deep and I put dig my heels into the system. But I think what happened was I experienced enormous. Uh, I, I I had developed something. I had invented something. I'd made the first measurements of protons and chloride inside organelles, and then I realized that I had developed something for which the applications were actually far into the future. And by accident, maybe you can call it accident, we didn't have the necessary infrastructure or the environment which would be needed so that this could find roots in India and then develop fast. So now either I can take one of two things. One is I can say, I can be sort of a little arrogant and say that, I will do it here in this place. And then it will take 25 years for the benefits to reach the public. Or I can say, let me put aside my ego and let me see where this can reach the people fastest. And then I looked around in the rest of the world. In fact, I went to Vijay and told him, he was my director. And I said, Vijay, this is what has happened. So it looks like I'm going to need to move. So then Vijay being Vijay, he just said, go, Yamuna, get a few offers, generate a few offers, and come back, and then we'll see. And so I was very happy because I didn't need to hide and go and seek a position. I just went to a few friends of mine and said, I have this new technology. Where do you think I might be able to find a good home where it can reach people fast? And immediately I got like 4 offers from 4 different countries. And I moved to the US because that is where the barrier between a very newly developed technology and the people, society, it's the least than anywhere else in the world. And that was why I left my friends, my family, my dogs, everybody. It was a sacrifice to leave them and go somewhere because you have to take something that you developed to its rightful conclusion. Um, I would not say that I faced difficulties, but you want to think about this in a slightly different way, where if a mother has managed to just realize that their child has the capacity to be the best marathon runner in the world, but they are born in a small country in Africa, but that kid needs to have the environment and the training in order to reach their potential. What should she do? Right? Should you keep that kid there or do the hard thing, move and learn something new? It will be uncomfortable for you because you're going to a completely new environment. But at the end of the day, you have an Olympian, that you've created for your country.
By the way, the best marathon runners come from Ethiopia. They are the gold medalists of all time. They break all barriers.
Yes.
We should not underestimate people from small countries. But let me also add, the country today is undergoing a tremendous shift in science and technology.
Yes.
The government has set up the Anusandhan Research Foundation, which is a parallel body for funding outside the Department of Science and Technology. There's the Research Development Initiative Innovation Fund, 1 lakh crore fund, which the private sector is going to govern. And this is going to fund researchers outside the government labs. So there's the ecosystem in India is right now churning and churning fast. जिसको कहते हैं ना समुद्र मंथन हो रहा है and the amrit will come because India wants to become a developed country. Let's spend a little time on mobility.
Yes.
We are talking at a time when America, which is now your home place, is undergoing a seismic shift, especially for research and development under President Donald Trump. The kind of actions and initiatives and anti-science efforts which we have seen are enormous.
Yes.
Now, What is your view on President Donald Trump's initiatives, and how are you coping with it?
So, in February 2025, on the 15th of February, these policies of removing anti-DEI policies, removing the strange attack on vaccines, putting people in charge of really amazing funding bodies for science. Actually started, it was an attack on science from inside. And so what has happened, it's not that the money has vanished, but the policies have been so egregious. There's been this huge shifting of priorities back and forth. He fired all the people in a nuclear facility, right? And then tried to unfire them. But, half of them have left. So it's a hollowing of all of these incredible scientific organizations, hollowing them from inside out. So what has happened is that they have let go of their expertise. And that is, I think, the most valuable thing. That was actually what made these science funding organizations extremely valuable. It's not the money that was there. Yes, there was money, but they had done it in a very intentional way, where they had very good systems of governance, really people who understood science really well to be able to disburse those funds in a very intentional way and make that money go further than it did. So for every dollar that was invested into science, the economy got back $2.35, right? That's a huge return on investment. And so what has happened now is that expertise, all these people have been mass fired. So all of these people, it's very hard to even rebuild. Even if now you say, okay, I want to rebuild, that is actually not going to be possible because this expertise has been gained over decades. And then you let everybody go. And these are people being people, they will move on with their lives, right? And they're not going to come back just because you call them back. And so this means that there's a huge lack of ability to even handle the money that is there well, right? Because you have lost your knowledge. So now, what happened, what we had experienced, I think if you ask me, because of this huge shift, right, it was extremely dramatic, was that we are all experiencing whiplash, right? So even if you say, oh, actually, I think I'm doing fine now, my science is still fine, I can still work, it's actually part, but all of these these decisions seem rather shocking or crazy. This is exactly what whiplash is, because right in the beginning, what you feel when you're rear-ended by a car is actually the emotional shock, right? The pain sets in later. So I'm going to tell you that we are going to start feeling the pain in 2026 onwards, and I think effectively by US is the biggest funder of science in the whole world, right? It is the one organization that, because of intentionally funding science, it actually shifted the center of gravity of science from the UK and Germany to the US, right? And so now, by saying that, okay, I'm going to remove all of these funds, I'm going to remove funding from science globally, and I'm going to focus it on my priorities. That is a bad thing for not just the US, it's a bad thing for all of the world. There are so many places in India that were getting funding from the US, so many places in Africa that were getting funding from the US, all to research emerging diseases, tropical diseases, etc. So many things, right? Energy, weather, right? And now we won't have these resources. So it's a time when I think it's with every catastrophe comes an opportunity, right? So I think now, if we are very intentional about how we want to use our money, I think there is a chance where we can, internationalize ourselves in a way where we can step in. My assessment is the way China has positioned themselves. It's a very strong contender to be the next, the center of gravity for science and technology. And that center will shift in the next 5 years. So effectively, the US ceded leadership to science. And when we look back, it would be on 2025. But I think if India has to sort of keep pace, we have to realize that we cannot do this the way we have been doing science in the past, which is a very insular, India only kind of an approach. We're going to have to partner. We're going to have to become international. We're going to have to work with other countries. And thereby position ourselves, right? Because China and South Korea have realized the international nature of science more than 30 to 40 years back. And that reality still hasn't been completely accepted by us.
No. I must say that this current government is focusing very strongly on that. Let me pursue a little bit on the Trump administration. So, how is the American scientist coping with this hard attack on science which is happening in America?
So, maybe I'll give you a couple of examples, right? I know of at least 2 or 3 people who have left the US and gone to Canada or to Switzerland. So you will start seeing sort of a brain drain out of the US.
Yeah, we saw the economist from the recent Nobel laureate and his wife both shifting to Switzerland from America. I'm forgetting his name.
Esther Duflo and Anirban Banerjee. So both of them moved, right? And these are the people I was thinking of. But you will start seeing this at all levels, right? Yes, from Nobel laureates all the way to young Indian scientists who, the Indian undergraduate who wants to do a PhD or a master's is now going to have second thoughts about, do I need to go to the US to do this, or can I go somewhere else, which is less xenophobic? And I would not blame them, right? You can do fantastic science and you can become a fantastic scientist training anywhere. I didn't step into the US till I was 40 years old. Right, I got my social security number at the age 40, right, when I moved. So everything I did was in India and in Cambridge in the UK, and so we have to stay competitive. So you will see an erosion, right? This is one of the things that is predicted, but also I think the American scientists deserve better. For the simple reason that the kind of innovation and the kind of fearlessness that they have when they do their science is really something to marvel at. I think very many times, I've worked in, at least 2 or 3 different countries. And when we have done our science, it's always been, a little bit conservative. You want to be able to do something which kind of is not too risky. But I think there they really embrace and celebrate risk. And that kind of a mentality is really something which is very unique. I've not seen it anywhere else.
Does this attack on science by Donald Trump's administration in America offer India an opportunity to attract the best brains? So from a brain drain going back to a brain gain, is that something which Professor Yamuna Krishnan, does that echo in your mind?
This is exactly what I was saying. It's actually an opportunity for our countries, right? So India, I think China is definitely doing it. They have been doing it for a long time. Same with South Korea. I think if India were to kind of like step up now and start thinking strategizing to see how is it that we can now attract a whole range of people, top to bottom, right, into this system, that would be one way to do it. Another way might be to have a sort of a policy that's at the same time, it's not that US science is going to go from infinity to zero in 1 year or 2 years. It's going to be a slow degradation, but it's still going to have a lot of, it's going to still be more advanced than many places in the world. One way is to say that we will have fellowships for a bunch of students to go abroad and study. And this is now this is something that South Korea and China have been doing for a while, right? But these kids go there, and then some of them come back, and they're trained, well trained in some of the best labs, and they come back and entrench those and modernize the place that they came back from, bringing back new skills. So one is to have an immediate pipeline of people that will come back, but also to create a pipeline of people that's constantly coming back, and then you have your infrastructure here, which, if you build right, allows you to kind of be within a few paces of China.
So if you were to give one piece of advice to Prime Minister Narendra Modi today, would that be get the best brains from America who are wanting to come from there, come and settle in India and fund them? Would that be a good advice to give?
Fund them in a way which allows international engagement, right? That it should be comparable to the kind of funding that they have had, with the levels of freedom to use that money in a way that is enabling, right? That's one thing. But also to start thinking about something very long term. Yes, you will have this first initial bolus, but if America recovers or whatever, you still need to have more people come back continually. And that pipeline needs to be created by having, let's say, a president's fellow or prime minister's fellows that are sent out, say, 1,000 people a year or something, graduate students or postdocs, with the idea that they will come back and set up. When the ones that are most successful, we can bring them back and offer them a pipeline to come back to India. That's something that I would do, but it's long term, right? You'll start seeing, it's a 10-year time scale vision.
Would you think India should have more women scientists? Because we have in the pipeline very few, and you are a rare role model who has succeeded.
50% of the workforce, is actually Indian women, right? That's a 50% population. And if we are able to make the environment conducive for women to come in and work, you will get the best. Because at the end of the day, women come to science. I've hardly ever seen a woman in science who says, I'm just here to get a degree. They are there because everybody has told them, don't go. But they've been like, this is what I want to do. It's their calling, right? And these are the people you want to encourage. These are the people who want to push boundaries. So I feel that there's always a need for women in science. I think as leaders, we are people who are able to look at not just what the person is capable of professionally, but what is the personal side of the person that allows you to get the best out of them. So I have seen some of the best managers have actually been women, right? Because they understand nuances. And people, at the end of the day, professionals are first people, right? And actually, if you look at us, one of our Indira Gandhi was one of the first women.
Absolutely. I was going to come to that as a woman manager, we've had great success. And I must point out, America has never had a woman president.
It is extremely misogynistic, right? We have had two people who nearly who stood for extremely competent people, right? But who didn't make it because there's a huge amount of misogyny. India does not have that as much, right? But we are capable. I mean, we have had women leaders up and down. Right?
Yeah.
And so I do feel it would be great to see in science what we have actually seen, in politics. Right?
Sure. No, we have a president in Draupadi Murmuji, who's a tribal leader becoming the president of the world's largest democracy. And we have secretaries of the government of India who have been women scientists, Professor Manju Sharma, Dr. Renu Suru, and so many. And today, the CSIR is run by the Director General, Dr. Kalai Selvi. We've had great women scientists and managers in India who have done well. Any message for youngsters in India who may want to take up a career in science? It's not easy, but it's not hard. You can make well.
So my own one bit of advice would be, don't listen to anybody, right? Not even me, because compliance and the desire to be liked by your boss is not going to make you the best scientist. You become the best scientist by questioning everything, right? Even if that requires you to be like not the favorite yes man of your boss. Don't listen, just think independently and do what makes sense, and always stay passionate.
Do you think India would be able to become a developed country by 2047 as Prime Minister Narendra Modi and the government desires?
I think that will require them to not throw money, but actually be very honest about what does it take to undo the knots that are currently in the system, right? That then will allow us to make the money work. But I think it really requires people to be very honest about where is it that are the pain points where we are losing. Otherwise, it's like a boat with holes in it. And if I don't want to look at those holes, I will just keep pouring money and it just keep leaking, right? I really have to look at the holes and plug them. And then I think we may have a chance.
Thanks a lot, Professor Yamuna Krishnan, for speaking to me. Delight trying to understand the complexities of doing DNA nanomachines to President Trump's whimsical attitude to science, and then trying to understand how India can become a developed country. A delight speaking to somebody who's had far too many connections in my personal life with alumnus and the same kind of mentors. So to be able to have that kind of connect and be able to talk to you was a pleasure.
Likewise,
Thanks a lot.
You've been a legend for all of us. We've all grown up, many of us in our generation, to documentaries and things from you. So it was also a delight for me to actually be having this conversation with you. Thank you.
Thanks a lot. So that was Professor Yamuna Krishnan, a professor of chemistry at the University of Chicago, a legend in her own right, trained in India, now making DNA nanomachines unique so that you can get therapeutics and diagnostics right at the level of organelles, which is the small parts within cells. So if you find sooner or later a cure for cancer, you may hear Yamuna Krishnan's name. Thanks a lot for speaking to me.
Thank you.
In Bangalore, Pallava, Bagla for NDTV.